Okay, hello and welcome to FS152. This is an actual 2022 recording, and today we'll be discussing the topic of electric power utilization. So kung kayo ay isang makulit na bata, malamang naranasan nyo ng makuryente. Ito man ay galing sa maybe touching an actual power outlet or a charge device, or maybe kayo isa sa mga nauto na dilaan yung dalawang terminal ng 9-volt battery. Either ways, that would mean you would have had first-hand experience that there is indeed a sort of power in electricity. And that thing that runs your electrical equipment is something that we could quantify, alright, and translate into energy for our use, for our benefit. Sige, without further ado, let's start. Okay, so ito po ay isang example ng mass and energy balance simplified diagram from Ingen-Heldman, wherein um, tayo ay merong 200 tons of tomatoes unprocessed, and we're gonna make 188 tons of canned and peeled tomatoes. And for each process, as you can see here, ay meron tayong kaakibat na energy consumption, whether it is in kilowatt hours of electricity, yung mga inverted triangle with a rectangle, and the semicircles are gigajoules from presumably fuel, combustible fuel. So as you can see here, each process has a corresponding electrical power consumption, or a translatable amount of fuel for usually heating. Right, so we can see here that to process 200 tons of raw tomatoes into canned peeled tomatoes, you need roughly, in this case, 179.5 gigajoules of of energy, amounting to around 4,500 liters of diesel fuel and 293.96 kilowatt hours of electricity. Right? So for those of you who are again familiar with your household electric bill, you probably have an idea how much energy 293.96 kilowatt hours is. So in our case, since we have one air conditioner running for our 3-year-old at night, we usually attain this figure for the summer months. Okay, so they get to consume um, in one processing of tomatoes enough electricity as we do in our household in a month, right? That is on top, of course, of the fuel they consume. For those of you who drive, 4,533 liters of fuel is a lot of full tanks. Now, usually, yung ibang full tank is anywhere from 30 to 50 liters. So, you do the math na lang. Alright? But again, our focus now is on the electricity part. So, saan nga ba natin ginagamit itong electric power in the food industry? So, of course, we have number one would be your lighting. Okay? So, maraming ilaw ang kailangan natin, lalo na high ceiling, and we need very high visibility in most areas. There's also heating and cooling, no? So, um, pwede naman yung heating manggaling siya sa fuels, pero minsan nanggagaling din sa electric source, depende no sa cost-benefit analysis or sa requirements ng isang food manufacturing. And syempre yung cooling, napakalaki niyan. I think I mentioned this before sa class ninyo. If not, itong ako po ay nasa paggawaan pa ng ice cream, yung Meralco bill po namin ay in the millions of pesos per month. Thanks in part no, to the very large walk-in freezers, essentially a frozen warehouse that has to be kept at negative 20 degrees Celsius. Right? We also have a lot of motors, things that spin, mga conveyor belts, and the like, metal detectors, lahat ng klase ng equipment nyo for mixing, agitation, extrusion, and lahat ng unit operations na gumagamit ng one or more motors to make the operation work. Okay? Of course, you do also have a lot of computer systems as well, lalo na in this day and age. Okay? Pati yung mga pneumatic systems, lahat naman yan ay electrically controlled pa rin. Alright, let's start with some definitions. I'll try to simplify, no, kasi kahit yung mga forum ng mga physics people and engineers nagkakatalo sila dito. But anyway, let's start with electricity defined as electron flow across atoms. So when you have electron flow across atoms, that simply means no na yung kuryente, yung energy from the electrical energy rather is not the consumption of electrons but rather energy from the electrons flowing being utilized to say run your electrical device, no? So much in the same way na kung meron kang mga balde na may lamang tubig, yung electron yung balde, yung energy yung tubig mo. Yung tubig yung nagagamit, hindi yung balde, okay? So anyway, so remember that your ampere or the magnitude of electric current is one of your base SI units and is defined as 1 coulomb per second, wherein 1 coulomb is the electric charge of 6.06 times 10 raised to 18 electrons. Okay? So, pag makikita nyo sa likod ng inyong appliances, usually meron kang 2 items dyan, no? Ano yung voltage ng appliance na yon at ano yung current or maximum current na pwede niyang i-carry. And then usually, when you look at wires, they are also rated for the maximum current that they can carry and not the maximum voltage. So take note of that, no? Usually, the thicker the wires, the higher the current can pass through. And if you go beyond what is the allowable current for that wire, iinit yung wire o pwedeng magkasunog. Alright, voltage. Of course, we know voltage from childhood. Alam natin yung mga sockets natin, 220 volts, and then your battery devices, meron kang 12 volts, 5 volts for USB, 3.7 volts for some of your cell phone and other digital device batteries. So it's simply a force causing current flow in a circuit. Sometimes this is referred to as the potential difference. No? Yung malinaw yung salitang potential doon. No? Imagine nyo, if you have a higher voltage, then for the same amount of current, then mas marami kang energy na makikarry. Okay? So think of it as, like for example, you have 1 liter of water. And parang potential energy, kapag yung same 1 liter of water na yon is on a higher elevation, then that water has higher amounts of potential energy. Parang ganun din, no? So, in an electrical system, all other things held constant if same yung electric current or yung number of amperes dun sa system na yon and you have a higher voltage, then you can deliver more energy as well dun sa ano man yung system na yon. Then we have also resistance, which is the measure or of degree to which conductors resist the flow of current. So it is what it is, no? It's a measure of how a material such as say a wire resists the flow of current. And of course, kapag higher resistance, minsan yun din yung mga mas umiinit. And then yung mga electrical engineer people, of course, gumagamit sila ng resistors din, if you remember, sa mga electrical circuits for various purposes. But as now, that's beyond the scope of yung discussion natin. So just to one major equation that I would like to point out is in determining usually the electrical power, it's usually measured as the product of the voltage of that system and the current in amperes. So 1 volt ampere is equal to 1 watt or 1 joule per second. Okay? So actually 1 volt ampere second is equal to a unit of energy na 1 joule. Right? So remember that for now. Kung meron man kayong isang tatandaan na equation na helpful in practical living, ito yun. Okay? Right, so again, we might probably have heard of DC and AC. No? Usually, yung direct current ay characterized by a simple one-way flow from positive to negative, and usually ito yung nakikita nyo sa mga baterya nyo. Our batteries, AA batteries, cell phone batteries, and well, even solar panels generate direct current electricity. On the other hand, alternating current, as the name suggests, nagpapalit yung direksyon ng daloy ng kuryente in a fixed rate, which is usually 60 times per second. Sa ibang bansa may 50 hertz din. Okay, and makikita naman natin ito sa mga transmission power lines and especially sa mga bahay natin, no? So, yung mga electricity generated from power plants are transmitted using high voltage alternating current, and then nilo-lower yung voltage pagdating malapit na sa bahay through the step-down transformers. As you can see, yung AC, dahil nagpapalit siya, kung mapapansin nyo yung mga AC sockets ninyo, di ba pag nagsaksa kayo yung dalawang plug, kahit baliktarin mo yun, gagana yung appliance, no? Kasi nga nag-alternate naman ng current. On the other hand, if you have a DC battery-operated device, such as maybe a flashlight using AA batteries, if you insert the battery incorrectly or in the reverse polarity, then that device wouldn't work. Kasi nga, one-way lang yung flow niya. Okay, we may also have heard of the terms single phase or three phase. So this simply relates to the number of windings in a generator, no? So as you can see, pag three phase, obviously then meron kang tatlong sets ng windings, as you can see in this example. Okay, and in three phase, there is a simultaneous generation of 3 AC voltages. So as you can see from the sinusoidal graph, aim lang nito is parang to make the generation of electricity smoother. Okay, and we'll explain more of that later. Okay, we also have the watt, which is a unit of electrical power equal to 1 joule per second energy per unit time. Okay. Also, ang base SI niya is 1 kilogram meter squared per second cube. So, for direct current, this is usually the product of the voltage and the current. So, for example, if I have a 60 volt battery on my electric bicycle and it's currently drawing 10 amperes of current, then I have a power output of 600 watts, which is less than 1 horsepower. Okay, then meron tayong tinatawag na power factor for alternating current. So it's a ratio of actual to apparent power with the value from 0 to 1. So parang yung mga efficiency lang na figures natin, di ba, wherein parang the actual power consumption is not equal to the apparent power being delivered. Okay, so parang losses, ganon. And of course, we also have the term of conductor, which are materials used to transmit electrical energy, and how much they conduct is based on how much they resist or do not resist the flow of electricity. Alright, so one simple analogy that we could use is yung tinatawag nating water tank analogy, no? Wherein if the total volume of your water represents the amount of total energy, say in joules, then the voltage represents yung parang potential energy niya represented by the height of the water in a tank, and therefore the pressure, the voltage is related to the downward force or pressure exerted by the water. The volumetric flow rate given by the cross section of the pipe outlet is equivalent to the current. So higher current allows parang mas malaking butas siya for water to pass through. And as we know, na kapag mas mataas yung level ng water sa tanke for the same pipe diameter, mas mabilis pa rin yung flow ng tubig. No, if you've tried maybe having a container ng yung 20 liter na water jug na may gripo sa ilalim, di ba? Mas mabilis yung daloy ng tubig for the same opening nung faucet mo if the container is full versus when it's say half full or something. Alright? And so for example, in this case, a low voltage high ampere setup could have equal energy output as a high voltage low ampere setup. Okay, especially if you're talking about DC, right? And the hose diameter, cross-sectional area, is more or less um, analogous to the resistance of that material. So I hope this helps us understand yung relationship ng voltage, current, energy, and resistance. Okay, so as a side note, let us briefly discuss yung Ohm's law regarding electric circuits. So maraming equations ito, pero sa Ohm's law, there's voltage is a product of current, which is I, and your resistance in ohms, which is R. And then for power, there are three equations that we use. I prefer this one for practical reasons, voltage multiplied by current, but it can also be expressed as the square of current multiplied by the resistance, or the square of voltage divided by the resistance. And then if you have a circuit wherein resistors are in series, for example, you have light bulbs there or something, then the potential difference across the circuit is given by the current multiplied by the sum of the resistances. Okay, on the other hand, if you have resistors in parallel, as is the case with this one, so the voltage is simply the current multiplied by the sum of the reciprocals of the resistors. On the other hand, if you have a somewhat complicated combination of resistors in series and parallel, so you just analyze them accordingly by breaking them down. So in this case, we could see that resistor 4 is in series with the circuit, and then parang yung resistor 2 and 3 saka resistor 1 naka-parallel sila, but resistor 2 and 3 is in series with each other, so collapse them here, and then we take the reciprocal of the sum of resistors 2 and 3 and the reciprocal of resistor 1 since they are parallel, and then we now treat this as the circuit being parallel to resistor 4 and the collapsed circuit, which is resistors 1, 2, and 3. Kaya magiging ito na yung final equation natin for this circuit. So anyway, though we can use this for calculations, but this is just to show that the resistances that are in the circuit, so mainly kung may nilagay kayo dyan na resistor or something na device like ilaw or whatever electrical component, they affect the calculation of the potential energy across the system. Okay, next, let's discuss electric motors. So ito ay isa sa mga pinaka-common na ginagamit sa halos lahat ng unit operation natin to utilize electric energy and transform it into mechanical energy. So regardless if it's something as small as the electric motor in your toy cars or those that you see in electric vehicles or even in large plant operations, they are more or less working on the same concept, no? So you have yung sa loob nung parang pinaka-cylinder na yon, meron kang shaft na umiikot, may bearings to reduce friction, there's an encasing frame, and then there's what you call the motor and the stator, no? So we have what we call an electromagnet, which is insulated wire wrapped around a soft iron core. Okay? And then a magnetic field is produced when current flows through the wires, and its direction is reversible with the direction of the current. So kung meron kang AC motor, then nagpapalit-palit yung direction ng magnetic field niya. And we also have electromagnetic induction, which is when electric current is induced in a circuit as it moves through the magnetic field. So as you can see in this photo, meron kang cross-section illustration. You have the stator, which is the non-moving part, the rotor, which is the moving part, and then wires that induce the magnetic field. So nagkakaroon ka ng parang north and south poles dyan. So the stator is the housing with copper wire bound iron cores that is connected to, in this case, the AC circuit for an AC motor, while the rotor is the rotating drum of iron and copper bar, so the spinning part. Um, that of course makes whatever it's attached to spin as well and operate your equipment. So here's a video you could watch. The link is there, and I'll try to put it as well in the UVLE page so that you can understand more how a motor works. Alright, so you may want to look at for electric motor selection, no? Kung anong klaseng power supply yung gusto mong gamitin, kung alternating or direct current, although usually sa planta AC yan. Although you could have a DC motor that is supplied with AC power. Then you could have either single or three-phase, and then you have to consider the application. Is it something that would run maybe for 24/7, like say yung mga conveyor belt, or something na intermittent yung operation, like let's say if you're using an industrial-sized blender or size reduction machine that only operates for minutes at a time. Okay. You want to know the type and size of load, whether you want constant power, such as in a conveyor belt, or something that could have a variable torque. Let's say when you want to adjust the agitation speed or the level of mixing or grinding. And then you have to consider the conditions. So some operating rooms are highly humid. Some others are dry. Some will have to be air conditioned, and you have to look at how much water is being splashed around the place. Of course, which is dependent on the type of food product you are making and the specific step involved in that production. Then you have to also look at the space requirements for the motor. And again, if it's harsh operating conditions, you may want to look at the IP rating for dust ingress and water ingress. Okay, moving on, we have electrical control systems. If you remember again from your food physics, sensors are there not just to give output on the physical parameter readings, but also to relay these information to a somewhat automated system. So you have transducers and programmable logic controllers as well, acting as a sort of a simple artificial intelligence that could replace some of the jobs done by humans. Instead of having physical switches pressed by human hands, you can have electromechanical switches, pressure switches, and relays that could automate the process. And the higher the level of automation, the higher the energy savings there is. No? Maisip mo, baka dapat baliktad yan kasi dumadami equipment. But then, because of the automation, you lower the reliance on manual labors and inspectors. So, actually, pati yung savings mo sa manpower, meron din. And you can even operate remotely. So, I've seen one food manufacturing plant wherein they have this control system, no, na talagang may computer room sila, and they can monitor the a single person could monitor, let's say, multiple tanks with batches of liquid product from a single room, instead of one person having to physically walk onto the shop floor and check, for example, the temperature indicator on each of the tank, or open each tank to see the level. And it also makes things faster, no? Kasi you can simultaneously monitor probably a dozen tanks or so without even moving from your chair. And it's a lot faster than having to walk back and forth and record everything manually, and that of course saves you operation time for the whole plant. So as for electrical lighting, obviously we need them first for illuminating the space. Alright, we have to look at how lighting is distributed, whether it's adequate for the intended purpose, the energy efficiency, even though lighting is a somewhat smaller percentage compared to, say, heating and cooling of your electric bill. If a small percentage of 4 million pesos, say 10%, is still 400,000 pesos. So, in the end, it's still cost savings, no? If you get more efficient lighting or just the right amount. Then there's also the concept of serviceability, because when you have malfunctioning lighting in your production area, that could cause probably errors not just for the humans but also for the sensors that may be dependent, for example, on lighting requirements. Like, say, if it's an optical based sensor, okay? So we need something that's easy to replace, etc., or repair. Right, so if you recall, one of the base SI units that we have is the candela, which is a measure of the luminous intensity. However, when you're gonna buy a lighting fixture, you're likely to be presented with either the lux or lumens. So ano nga ba yung pagkakaiba ng mga to? So we start with candela, which is the strength of emitted light. It is direction dependent but not distance dependent. Think of it this way, okay? So if you have a laser pointer, that transmits light only in one direction. So parang if you're gonna look at it in pitch black, no? Pag direktang tinatamaan ka ng laser pointer, mataas yung luminous intensity niya. Pero pag ipinlace mo sa likod or gilid ng laser pointer, halos walang luminous intensity yun. As compared to, let's say, a candle or a light bulb, which would have more or less the same luminous intensity from anywhere around it except siguro yung sa bandang likod ng light bulb, no, na part. On the other hand, lux is illumination on an area. Therefore, this takes into account the strength of the light hitting a surface from a certain distance, no? So, even if you have the same light bulb, kung halimbawa yung distance ng ceiling to the floor, for example, is doubled, then if that would lessen the lux or the illumination on that area for the same light bulb, no? On the other hand, lumens is a measure of the total light radiated, and therefore parang sinusukat mo lang yung quantity ng light from all directions, and in that case, it's neither distance nor direction dependent. Okay? So there, and we'll have an illustration in the next slide to more or less clarify this. Okay, so assuming we have a 1 candela light source, meaning hypothetically in this case from any side mo siyang kunan ng luminous intensity is 1 candela siya. Okay, if you project 1 steradian solid angle, then that would be a 1 lumen, okay, na total light per steradian. And then if that 1 lumen per steradian is projected from a distance of 1 meter, tapos 1 square meter din yung projection area mo, then that is equivalent to 1 lux or 1 lumen per square meter. Okay? So I hope that gives you an idea about their differences. Oh, by the way, ito pala yung foot candle, no? Yung, of course, the non-SI counterpart, which is 1 candela luminous intensity measured from 1 foot away, illuminating an area of 1 square foot. Okay, tingnan naman natin briefly yung mga iba't ibang klase ng lighting sources. So, when you were younger, probably na-encounter nyo pa yung mahiwagang incandescent bulb and their counterpart, the halogen bulb. Okay? So, they operate by heating up a tungsten filament to a high temperature under vacuum pressure inside the glass. And because of that, it produces light. This is one of the oldest technologies, and there are light bulbs that are over 100 years old na incandescent, and they're still up and running. However, they're one of the least energy efficient. they generate much more light, much more heat than light. Kaya ito yung madalas yung makitang ginagamit pang warm ng mga chicharon na binebenta dun sa mga glass cases, no? Okay. So anyway, gutom na ako. Yun. So, yung halogen bulbs are similar except that from the word halogen, meron silang inert gas doon sa loob. And these are usually seen as small bulbs with very high power consumption and very high light output compared to the much bulkier incandescent bulb. So, despite having the advantage of possible longevity, lalo na kung constructed sila properly, yun nga, medyo magastos sa kuryente, so global warming at its finest. So, we also have the fluorescent and compact fluorescent lamps or CFLs. So, either yan yung pahaba na puti na mukhang lightsaber or yung mga ganyan na toroidal or parang nag-u-turn na mga bulb. So, what makes them unique is the use of mercury vapor. So, hindi siya basta-basta dapat tinatapon pag napundi kasi may kaunting mercury sa loob yan ng glass tube. And it is ionized and causes electrons to emit photons at UV frequencies. So, kaya kino-coat din yung loob ng bulb para yung mga UV frequency na yon ay maging visible. Okay? So, phosphor coating yung gamit dun sa loob ng tube. And there are special control mechanisms, yung tinatawag nating ballast to control voltage and current. Kaya di ba pag may CFL ka or fluorescent lamp, minsan pag nag-on ka, hindi siya instantaneous. Like there's a second or half a second na delay bago siya mag-on. Especially for yung mahahabang fluorescent lamps na ginagamit sa mga lumang bahay, no? Yung tubes. So I forgot to mention that yung mga CFLs, they are much more energy efficient than the incandescent and halogen bulbs, but of course they don't hold a candle, pun intended, to the light emitting diodes or LED. So these are the latest technologies, and so kung nakita na kayo ng ganyang klase ng LED, ayan, merong semiconductor sa loob, and when you pass current into it, nag-release siya ng photons and thus visible light. So, ang downside lang talaga nito is mahal yung kanyang upfront cost. If you know, the cost of a LED bulb is somewhat comparable to a CFL or almost twice as much in some points, or maybe more than twice as much as the counterpart niya na yung incandescent. However, of course, we know that LEDs are usually the most energy efficient at this point, and compared to CFL, mga factor of around 1.5 to 2 times yung kanyang efficiency, and compared naman sa incandescent, maybe 4 or up to 8 times more efficient siya, no? So, you save a lot on energy, greenhouse gas emissions, and so on, and it generates less heat as well, no? So, I didn't really pay much attention to this until my wife pointed out that she wanted lights turned off because when they're on, mas mainit daw yung kwarto. But when you look at it, regardless of whether you're using LEDs or incandescent, they all emit substantially more heat, or they use more of their energy for heat rather than light. Okay, ganon. So here's an example of comparison I found online. On operating costs for the bulb, so and how long bulbs last, as well as efficiency is usually measured in lumens per watt. So per 1 watt of electricity consumed by your bulb, how much light does it give off? And as you can see here, obviously in this case parang definitely panalo yung LED, and pinaka-olats tong si incandescent. Okay? So, andyan din naman yung kanilang advantages and disadvantages. So, you can just browse through that. And when we're looking at different types of activities, there is a lux level. So, take note when lux, it's projection on an area, di ba? na kailangan. So we need to measure this if we are designing, say, a plant or a laboratory or another whatever tawag dito, a building. So architects need to take note of this. And usually sa lab, yun yung pinakamataas na kailangan kasi syempre, halimbawa, napaka-critical nung ginagawa mo, you can't afford to mess up. And that's why if, for example, you look at properly designed rooms, they would usually have a lot more number of bulbs than say compared to your house na may isang bumbilyahan sa sala, may isa sa kusina, etc. Pero pag pumunta ka sa mga buildings, like there's a light bulb for every square meter or something like that, no? And mas maaliwalas yung ano nila, yung space kasi malakas yung ilaw, right? Okay, so let's just look at some publications noong related to LEDs as a new technology. So they have proven to have a longer theoretical lifespan, better color rendering, and very high efficiency. However, even though costs are going down, relatively higher pa rin siya. This year medyo bumaba na, no? Lalo na nung pre-pandemic. Problema is because of its complicated production process, marami ka nabibiling LEDs that fail prematurely, and other than of course the many components involved in its electrical system compared to the simplicity of say an incandescent bulb, poor heat dissipation is the one of the best causes ng pag-fail niya. Now if you would notice, karamihan ng mga LEDs meron silang heat sink, so merong bakal na ventilated dun sa taas na yun yung nag-absorb ng heat because excess heat could kill off the LED circuitry prematurely. Okay, so again, hindi pa siya fully developed as a technology, but we're seeing now na more and more nagpapalit na yung mga tao from incandescent to CFL to LEDs, considering the cost savings. Of course, for a household, the savings may be very small, something like maybe 10 pesos a month or so, or less than 100 pesos, depende kung gaano karami ilaw nyo. But compared to its cost ng bulb over its lifetime, medyo significant din yung savings mo per bulb. Okay? Alright, as I mentioned earlier, despite LEDs being much more efficient than its counterparts, it still produces a lot more heat than light. No? In this case, 75% energy is released as heat, while 25% is used to produce visible light. Of course, let's say sa incandescent, mas mataas yan, like 90% heat generation and only 5%. So if you had a 100 watt incandescent bulb, for example, that would generate 90 plus watts of heat as compared to a 100 watt LED which only produces around 75 watts of heat. But that's still a lot, no? So one proposition is to redirect the heat produced by LEDs to the outdoor during the summer, okay, parang ventilation, and use it for heating during winter. Okay, so ano bang nahanap nila sa study na ito? 70.3% of input power was removed as heat in the summer. So therefore, it will help prolong the life of your LEDs and even somewhat help cool the building. And for winter naman, you're utilizing energy balance, di ba? The heat produced by the LEDs to heat the space to lessen your heating bills sa whatever it is you're using for heating. Okay? This resulted in thermal loads reduced by 7.5% for heating and 1%, 1.4% for cooling, respectively. So again, this is just a matter of energy balance being practiced and at the same time lengthening the bulb's lifespan. Two birds with one stone. So here is just a simple schematic of their diagram, no? So you have a LED light here. Nandito yung parang heat sink niya, hindi na-absorb niya yung init galing sa LED. And then you have air blowing through para palamigin yung heat pipe, similar to how, PC cooling fans behave or something. And then air exits through the duct. Okay?